Hello everybody, Marco Chiappetta here, and I am with NVIDIA in New York City, and I have some very special machines and demos to check out. I'm with Justin, and he's going to show you some really cool things some new RTX Spark-based Microsoft laptops can do.
All right, so here we have the Microsoft Surface Laptop Ultra. This is our new RTX Spark. Right here we have Alan Wake 2 running. This is using ray tracing. It's just showing that the RTX Spark, while it can do AI workloads, content creation, it can also game really well. The RTX Spark is going to support all of our latest tech. So we have ray tracing, DLSS, Super Res, frame generation, and this is actually showing, this is our older model of array reconstruction. But as you can see here, these TVs should actually be flickering, having some static. But when we stop moving, that older ray reconstruction model interprets that kind of static as ray trace noise. So it suppresses that. With the new model of ray reconstruction, DLSS 4.5, it brings that back. So it's bringing back the original artistic intent as well as the associated lighting with that. So it's just showing that the Spark is going to support all of the latest RTX technologies.
Yeah. So DLSS 4.5 ray reconstruction already running on Spark at this early stage.
Yep.
Very cool. And what do we have next to it here?
Here we have, this is Unreal Engine. So we have a demo here. Typically, game devs are going to be working in an unlit area. Let me slow down the speed here. So game devs might be working in like a small block, unlit, just to kind of break up their workload. They can't load a lot of things into video memory.
Yep.
With 128 gigs available to us in that unified memory, game devs are empowered to work in a fully real-time lit world. And they're not constrained to like working in a singular block anymore. We actually have 80 gigs loaded into memory here. So this is actually the entire city right here. And we're able to actually load this all in memory in real time.
So that's like an RTX 50 class GPU, but with access to 80 gigs of memory right there.
Yep.
Unreal Engine.
Yes.
Very cool. And what about this last one over here?
This last one is our AI coding agent. Step in here.
Yeah, so this is showcasing how we can use RTX Spark Laptop as this platform that is built from the ground up for local AI coding agents. So what we're showing here is we've set up our custom harness, and this is running the Qwen 3.635B model. And we're going to show how we can leverage this to offload a lot of like the repetitive development Q&A tasks that would usually bog down a typical developer that's working on a product. So what we're looking at here is our project that we're currently maintaining with a few other developers. This is just for like the Parkside Badminton Club. So users are able to reserve courts and play at this club. But it looks like it says that there's 8 slots open, but there's no actual slots showing up in the app. So maybe this was some issue or regression that occurred during the night that we didn't expect. So we can actually tell the agent to investigate this for us. Okay. So we can simply ask it.
So you're going to ask the model to troubleshoot the website and figure out what's going on in the code there.
Exactly.
Awesome.
Yeah. And we can also, because we have so much memory stored on the device, we can load in this large local model as well as a speech, text-to-speech and automatic speech recognition model to talk in natural language. So we can ask it really quickly, hey, can you investigate all the issues that came up overnight? We can send this in, and you can see that came back super fast. Because of the high coding and reasoning abilities of the Qwen 35B model, we were able to hook it up to some skills and MCP servers. So it's able to easily pull all of our information of like the latest Git changes that have been going on.
Okay.
So you can see here, this looks kind of related to the issue that we were looking at. So we can actually have it attempt to fix that issue for us. So can you investigate that top issue and fix it?
Let me investigate.
And you can see it immediately goes into triage mode. It's able to ingest all of our source code, all of the changes that have been done to it. And on the back end right now, it's looking through to see like what the potential issue could be. Yep. And once it finds it, it does like a detailed analysis and patches it.
How big is the model that you're running right now?
This is a 35 billion parameter model.
So how much memory is that taking up on that system?
Oh god, it's like probably up to like 60 to 70 gigabytes of memory.
Nice.
And also because there is some extra headroom with the 128 total gigabytes of memory, we're running again those like other two local models, and you can run other resources on top of that. Yeah, so it looks like it attempted to do a patch. And typically at this point, you know, we would see devs kind of go back themselves and manually do a QA pass, make sure things are functional, but we can actually have the agent test that itself live.
Okay.
Can you do a quick QA pass before we make a pull request?
Running a QA pass.
And what it's doing now is actually taking control of the screen through the use of a computer use agent. And I'm completely hands-off. The agent's doing this itself. It was able to spin up a development test server, and with some mock information that we provided, it's able to validate that everything works as expected with the fixed features of adding in those quartz back into our application.
Gotcha.
And then once that all looks good, what's great is that you could run this like autonomously over all issues that come up overnight.
Sure.
So when you wake up, you can just focus on continuing to develop new features instead of having to fix these bugs.
Just check it out, make sure everything looks good, deploy it live, and you're done.
Yep.
Awesome. Very cool. I appreciate it.
Yeah, of course.
Thank you so much.
Thank you.